Welcome back to Audio Academy. I'm your host, Bowmancer Edwards, and you are a creative individual on the precipice of an expressive breakthrough into the world of immersive audio. That is our vibe today. Okay, let's talk about what we're going to cover in this episode 2, the Creative Sound Design Toolkit. Let's discuss our custom assets and the format we want them to be in. Let's discuss and understand the sound event engine, the capabilities, and how we can approach problem solving and creativity. Let's discuss in detail the sound event properties. Let's keep a little surprise at the end, shall we? For your custom audio assets, Source 2 prefers using WAV files at 44.1 kHz, mono and stereo files. But there is flexibility. I've seen MP3s and 48 kHz be used. And also, stereo width is something that we will control later on in this video. So it is now time to open the File Explorer. We're going to go to our add-on, into the Sounds folder, and then we're going to get our custom assets and bring them into that Sounds folder. And we're going to probably make some new folders in the Sounds folder. We're going to organize things, keep it nice and dandy. And the moment you're done making new folders, I want you to reboot Hammer, because Hammer does not auto-populate new folders or changing the names of folders, so you need to reboot Hammer to recognize the changes. Looping in Source 2 has yet to change. To make an audio file loop, Source 2 uses embedded Wav Markers. Place the marker at the beginning of your loop point, which isn't necessarily the beginning of your sound. Like, for example, the valve asset Vent01 sound. Wav markers are often automatically added from software like Logic Pro to cause unwanted looping, so it's a good idea to check your assets. For best wave marker placement, it's best to design them inside your sound design DAW. I use Reaper as my primary sound design DAW, but an easy alternative that I also use a lot is called Wavosaur. It's a freeware, and what's really great is that it just immediately gives you the buttons to manipulate the wave markers. And when you save, it overwrites the original file, so it's destructive saving, so just be cautious with that. But you'll find it's actually a nice feature when you just want to get things done really quickly. So Wavosaur, please sponsor me. Here I am talking you up. Anyways, one final consideration with looping in Source 2 is if you have a spatialized looping element and you are inside the range and you're listening to that sound, if you exit the range and you re-enter the range, the timeline of that looping sound is going to be reset. So if that's a spatialized piece of music like a radio, every time you walk into that radio, you're going to hear the exact same fade in every time. So that's just something to consider. Our raw audio assets like WAV files or MP3 files are automatically compiled into the vsnd format, and they are also recompiled upon selecting in the asset browser. Sometimes it feels like your assets are not previewing properly. What you can do is open up your asset browser, view only sound assets, select the first asset, hold down the right arrow key to scan through all of your assets, and this should recompile all of them and fix any problems. Our WAV files are always going to be WAV files in the content folder, and the vsnd files are going to be located under the symmetrical hierarchy under game. So vsnd is basically just a file that the game engine is ready to use. So that is the formatting for the raw audio in our add-on. We have one more asset we use called the Soundevents file. This file is a text file located in the Soundevents folder. It is going to be hard-coded and named soundevents_addon.vsndevts. The Soundevents file contains all of the audio implementation and instructions for our add-on. Everything outside of the vmap, that is. The vmap might have some other stuff going on. But this Soundevents file will be updated constantly as you tune your sounds, and every time you save changes to this file, it automatically recompiles the changes and updates them to your game engine in real time, so all future sounds after that moment are now going to be updated with the changes, and any ongoing sounds are not going to be updated. Now we begin the sound event portion of our program. This is where things really matter. This is how we mix our game to detail. This is where we put a little extra creative flair into our sounds. And if you're feeling that little extra, you can put it into a comment, like, subscribe, because this is some solid, sturdy knowledge I've put together for you. You're really going to appreciate it. All sounds are implemented through sound events. Let me provide a bird's eye perspective on all the ways a sound event can be called to play in your game. The entity point sound event can play a sound event at that location, or perhaps that sound event has a specific location in its properties that it will play at. The entity env soundscape can launch a soundscape. Soundscapes are sound events. They are a type of sound event with extra implementation built in. A soundscape has many functions. Only one soundscape can be active at a time, and they will automatically transition with a crossfade. Soundscapes can trigger other sound events at random intervals and randomized locations relative to player, or with world coordinates. Soundscapes will also assign a reverb preset for all sounds in the environment. Animations can also trigger sound events by embedding them into the timecode of the animation. Some sound events are not triggered through entities or through soundscapes or animations, but they are triggered by the game itself for things like the round starting and the music at the menu, stuff like that. All of your map sound events in Soundscapes are located in one file, the soundevents_addon.vsndevts. This name is hard-coded, so that's the name we're going to keep. Inside of this file, we have some templates and some tips, and I suggest making a copy of this file and saving it somewhere, just for reference. So let's begin to understand sound events. A sound event is a name that references an asset with the vsnd files track 01, or it references other sound events with the sound event 01, or it is a copy of another sound event which can then be modified when you would do that with the base property. One way I like to be creative with sound events is to use the point sound event and the sound event picker to pick a sound that already exists, like a water sound if I need it. I select that water sound and I copy the name, and then I create a new sound event with the base equals property to then use that asset, and then I can change the pitch of that asset to fit what kind of size water I need. I don't have to create a new water sound from scratch, I can use what's already there. To audition the changes to your sound, return to your sound event picker and click the sound to refresh it. So before we get into the nitty-gritty of sound events, I want you to adopt this attitude that it's a creative tool and it's a solution and it can generate new sounds, and it's not just some sort of obstacle you have to crawl through, it's actually a useful tool. And now we can design some incredible audio experiences for our maps. Let's do that! So every sound event is a name, and then equals, and then brackets with all the properties on the inside of those brackets. You could entirely sufficiently create a sound event with one property, the base equals property. If you're not using the base equals property, you'll need to use type equals CSGO mega. And I'm not going to say underscore anymore, I'm tired of that. If you want to reference your custom audio asset, you'll use vsnd files track 01 equals quotation filepath.vsnd quotation. Now make a note here, it's not .wav. We are referencing the compiled WAV files, which are .vsnd. And if you want to randomize between multiple assets, you can include them like this with a comma after each asset. If you want to create a layered sound with multiple assets playing together, you will use sound event 01. The name sound event 01 sort of suggests that it's just going to have one sound in there, but actually you're going to include all of your sound events in a list under this property. So that's it for all the essential sound event properties. These next properties are optional. Let's talk volume. We got volume equals, classic. We also have volume random max and min for randomizing, very good. The next property controls the relationship between distance and volume, so how far away your sound is audible. You need two properties for this, the distance volume mapping curve and the use distance volume mapping curve. So the mapping curve looks kind of complicated, but we're really just plotting data points on a graph. The first number is the distance, the next number is the volume. The next two numbers are 0, 0, and then 2 and 3. And it's some kind of calculus, but what I know is that it results in a straight line between the data points. So that's one data point, is 0, 1. 0 distance is full volume. The next data point is 1000 distance and 0 volume. So we have a straight line from 0 to 1 volume across 1,000 units of distance. Pretty easy. If you want more data points, you can just add more data points. These next two properties work together to function as a fade-in curve called time volume mapping curve and use time volume mapping curve. And what's nice about this is that you can have a fade-in apply to a randomized pool of assets, and you don't need to print the fade-in on the asset itself. This fade-in curve will handle that. So like the other curve, we are plotting data points on a graph, and every data point is in brackets and has 6 values to each data point. The first value is the time in seconds, the next value is the volume, and then we have the usual 0, 0, 2, and 3 for the shape of that line. And the next data point is 1.5 in seconds, and we have a volume of 1. So we have a fade in from 0 to 1 volume across 1.5 seconds. These next two properties function as a fade out curve called fade time volume mapping curve and use fade time volume mapping curve. And the data points are just like the fade in. We have time, volume, 0, 0, 2, 3. For the pitch property, 1 is the initial value, and if you increase that to 2, your sound will go up an octave, your sound will be twice as fast, and it'll be half as long. And so pitch and playback speed are actually one and the same, and that's how this DSP functions. We also have pitch random min, which is a negative number, and pitch random max, a positive number. Occlusion is a type of audio processing for sounds that are out of line of sight, behind a wall, behind objects, and this will muffle the sounds to keep them from sounding as present as they would if they were in your line of sight. So we engage this with occlusion equals true, and we can set the intensity with occlusion intensity equals between 0 and 100. This next property is used to control the stereo width of your sound across distance. This means that you can set a range where inside this range your sound is fully stereo in both ears exactly as the wave file is intended, and then after you exit this range you set a ramp for how the sound becomes mono and positioned in the game engine, not in both ears. This property has a lot of potential to magnify the presence of your stereo sounds. Let's say you have a big heavy train passing by really fast and your sound file has a lot of stereo energy bouncing between the speakers. And when you leave this range, that stereo energy is actually going to be summed and diminished. And you'll have a significant shift in the experience and it won't sound as present as you leave the area. But when you return to that area, you will return to the stereo width and it'll sound very immersive and awesome. This property is called distance unfiltered stereo mapping curve and use distance unfiltered stereo mapping curve. Now, like the other mapping curves, we are plotting data points on a graph with 6 values per data point. The first value is the distance. The second value is a float from 0 to 1, where 0 is a spatialized sound in the game engine and not forced in both ears. A value of 1 is a fully two-dimensional stereo playback, forced in both ears, exactly as the raw wave file is designed. The other 4 values are calculus to set the shape of the line, and if you use 0, 0, 2, 3, that is a straight line. Alright everybody, let's take a nice little breather. What we've covered is the sound event properties for sound event children. These are individual assets that are going to directly result in what the player hears, and let's now compare that to a sound event parent. And a parent is just a sound event that references child sound events, other sound events. So now we're going to cover the sound event properties that are specific to parent-child relationships in sound events. So this is most relevant to Soundscapes and the sound events they reference. As a quick little recap, this referencing of sound events to other sound events is done with the property soundEvent01, and including that property designates your sound event as a parent in the hierarchy, and the references they make are the children. I've experimented with a 3rd tier hierarchy of grandparent, parent, and child, but the results weren't stable and resulted in errors, so I'd recommend sticking to just parent and child. and your child sound events should not use the sound event 01 property. Reverb is a type of processing applied to all sounds in an environment, and the reverb preset is selected by the active soundscape. And so when you make a soundscape sound event, you will use the property DSP preset equals, and you'll choose a reverb from this list, and that will set the reverb while you're in that soundscape. But you can also override the soundscape reverb preset on an individual level to the child event. On your child sound event, you can include override DSP preset equals true, and then include a DSP preset equals with a preset in there, and your sound, this child sound, will have its own reverb processing separate from the soundscape. You can control the position of a child with just $20 on Amazon. It's an easy purchase. No, I'm kidding. Use the property world position equals true and the property position equals. You can get these XYZ coordinates by opening Hammer, creating an entity where you want the sound to come from. In the object properties, under transform, right-click origin and copy, go back to your sound events and paste. Now you'll want to remove the quotations, add brackets and add commas, and change origin to position. For the child events of a soundscape, you can have them located relative to the player by using position relative to player equals true. And then use the properties randomize position min radius and randomize position max radius to set the range of the sound. Soundscape children are set to play only above the player on the z-axis, but if you use the property randomize position hemisphere equals true, then sounds can play above and below the player. Now for soundscape children, we usually want these sounds to be retriggered intermittently at random intervals as long as the player is in the soundscape. We accomplish this by using enable retrigger equals true, retrigger interval min with seconds as a unit, and retrigger interval max. These next sound event properties are not nearly as dramatic as the rest. They're not as essential. These are lesser important properties. The property Mixgroup equals is going to assign how important the sound is to the gameplay of the player. If it's Mixgroup equals ambient or world, it's not that important, and it's likely to be ducked in priority of other sounds like weapons, Foley, and UI. These next properties are used to control how many instances of that sound event can be active at one time. To do this, we use block matching events equals true, which globally blocks the sound event from being played twice. Or we use block match entity equals true, which blocks the same entity from triggering twice. Or we use block distance equals with a distance number, and this blocks the sound from being played twice in that range. Now, I've been saying twice as a reference number for the limit, but you can actually set this limit with instance limit equals number. The delay property will delay the sound event by an amount of time, and this could be useful if you're trying to choreograph many sounds under one parent sound event, and you want to delay one of the child sound events by an amount of time. vsnd duration is going to send a stop sound command to your sound after that amount of time, which will then engage a fade out if you have one. Preload vsnds equals true will preload your sound into RAM so that it can be fired as snappily as possible for the best audio-visual synchronization. It's really used for guns. That's about it. So we have quite a toolkit established. Sound events. Look at that. Great. Alright everybody, welcome to the final chapter of our video, the Creative Sound Design Tools. What we have in store for us right here, right now, is a little bit of a secret sauce from Bowman Bowmancer himself. This is a live coding demonstration. This is how I make iterations to my sounds in the most speedy possible way possible. You're all going to really appreciate this little part of the video, I promise. And the way I like to start my coding sessions is with a little stroll through the outdoors. Okay, you know, we got to appreciate nature. And then when we return to the indoor soundscape, we are fully recharged to now leap into our coding sessions. And we're going to start coding with the console. Going to the Sounds tab, and we're going to look at these two buttons up here. The first button sort of toggles on and off this whole analysis metering window. So if you see in the bottom, it says running, and you click this, it says stopped. So let's keep it running. what we really want to have happen here is we want to click this button, Visualize Sound Events. And what this does is it puts a file path floating on the horizon, and that is the asset we hear right now. And if we change Soundscapes, we'll notice we have some different assets. Now, what exactly is happening over here? Okay, we have a blue sphere floating in the world with sounds coming out of it. This is the origin of the whole vmap. This is the 0, 0, 0 coordinates. These sounds are coming from here because they are not spatialized in the engine. They are placed directly in our ears, and for that reason, they don't need to be anywhere in the world in particular, so they are put at 0, 0, 0. Okay, I want to now hit the code. Let's crack open the sound events file. In the sound events file, I'm going to type in the search, I'm going to search Scape Outdoor, because that's the name of my Soundscape Outdoors. Here we have my soundscape. We have a few properties. The base property is copying a sound event. So I made a base sound event for my soundscapes that they all copy. This is sort of like the structural elements that I don't want to copy paste individually. So they're all placed right here. I have a reverb preset, and I have some sound events I'm using. And if I wanted to get creative, I could just start copy pasting, and now I'm creating iterations to my sounds. What are we doing? We're adding some things. Okay, I created a new sound called things in the sound event. Now let's specify what these things are. So things equals, and then we have some brackets. Okay, inside these brackets, what's it gonna be? We have a base equals. What's that gonna be? Well, we're gonna go to the sound event picker, and I'm gonna bring up a sound. It's gonna be loud. Okay, hold your ears. 3, 2, 1, loud. Boom. That is a gunshot from the op, the biggest gun in the game. And we have now copied that sound into the things, and the things are now in the soundscape. And if we save, we go back to our game, we check our console, and what we are looking for here, okay, don't mind the clutter. Okay, it's gonna scroll. And what we are looking for is a piece of text about sound events. So here we see I have vsnd in the search, and it highlights vsnd stuff. And we'll see reloading resource 1 out of 1. Boom. This is a successful asset loaded here. Great. So we are in the game to now make things happen. And let's see what we got. Imagine the op in the game. Here we go. Boom. Over there. At the origin 0, 0, 0, the op is instanced. Boom. There we go again. Okay. So it's working. Great. That op is happening at the origin, but let's make it happen relative to player. So what we do is we type position relative to player equals true. And this is a loud sound. So I'm going to adjust for that right now. We're going to protect our precious little ears. Volume 02. Boom. Our sound is happening right above us. Great. And, we're going to repeat it to make sure we know what we're doing. Great. There is our op. Cool. So that is our sound, but let's enable the retriggering. We want this to happen intermittently around the player. And it's going to happen on top of the player. And this interval is going to be about half a second. And the max is going to be a little bit more than half a second. And so now this op will happen every half a second. Cool. Now let's randomize the position of this sound. Randomize min equals 500. Randomize max equals 900. So now we have a sound happening somewhere around us. Can't see anything. There you go. If I stop looking, it'll probably just show up in the screen at some point. Okay. Great. Something interesting happened. We have a stop in our sound. So something happened to our sound to stop it. The game engine can be overwhelmed and it'll just quit. If you have a sound that's very exhausting, it'll just quit. So if I set this, for example, to happen every 0.2 seconds, it'll give up very quickly. Okay. It usually gives up by now. Okay, there we go. It stopped. It gave up. It said too much. Well, notice two things happened. It stopped. There's no more ops. But also, they were interrupting each other. You'll notice they were kind of cut short. And that will happen because the game has already defined the instance limit of this sound. And if we put in our own, we're going to overwrite the other instance limit. And now we have our own. Great. Okay, great. So you notice they were not interrupting each other, and also they did not overwhelm the game engine because the game engine didn't have to think so hard about stopping all the previous ones. So yeah, that's some good stuff happening, making our sounds, happen the way we want them to happen. Let's start adding some reverb to our sound DSP preset. Let's do small tunnels. Okay, great. And let's now see what happens with some reverb on our sound. Oh, but look at that. We actually have a few things happening here. I hear the indoor soundscape. We are not outdoors, and I don't hear any ops. So the fact that the soundscape didn't change is a clue. And when you have a clue, you definitely want to go to the console and look for all the clues you can get. Oh, and red text is absolutely a clue. So we see a vsnd in red text. We are now workshopping and troubleshooting what exactly went wrong here. So here's our file. And what this tells us right here, these numbers, is what line of code and what digit of code had a problem. So 2501 and 2485 also. Now these are clues. They aren't exactly exact. So let's actually look at that one more time because I already forgot. So 2501, 2485. 2485 is the start of our sound. And 2501 is the next sound. So we know there's an error somewhere in between here and here. And I can tell you, I made this mistake on purpose to show you how to account for your mistakes and troubleshoot through them. So I deleted the extra colon. I saved, and now we go back to our console, and we are going to look for, geez, I hope I'm scrolling. Okay, we look for this reloading resource 1 out of 1. Boom, that means we are successful. So let's go back to our Soundscapes, and the op. Boom. And this reverb is sort of hard to hear. Gun reverb in Counter-Strike is actually very soft. It's really the Foley that has a lot of reverb. So what we can do is reverb wet equals 5, because this is not a 0 to 1. Most audio has a 0 to 1 mix, but actually in Counter-Strike it's a float, and if we want 5 times volume reverb, we will get it. There we go, 5 times the reverb on our sound. Alright, well, I am feeling pretty comfortable with what I've shown you in this video. If your sound is a start on sound, a start on spawn kind of sound, it's not going to be very easy to iterate just like I did here, but with Soundscapes, you are absolutely empowered to iterate them live, just like that. And let me tell you, you've put in some good effort to watching this video. I've put in some good effort to making this content for you. So if I could get your lovin' in return, if I could get a like and a comment, subscribe of what you're up to, because, dang, I am trying to connect with my people out here, and y'all are deserving the best, and I want to give you the best, and if we can just help each other out for a second here, I'd appreciate it. So like, comment, subscribe. But also, what I want to see is the best audio we can get for the Counter-Strike 2 community. So whatever you're up to, let me know. Drop it in Eagle on Discord, drop it in the comments. We are going to be creating the best audio we can together. We are on a team here, and we are trying to make the world as entertaining as possible. So with that, I want to send you all on your ways to now design your grand audio immersions. And please, keep that loving in your hearts. And I'll see you all in the next video. My next video is going to be an implementation demonstration, some very specific designs I made for this map, the jailbreak map. So it's going to be kind of like an inspiring, like what even is possible on the grandest scale. And you're all going to really appreciate that one as well. So take care, everybody. Bless up, and I will see you in the next video. Peace.